Welcome to Wednesday. Let's see here. A little late in starting because I was trying to resolve that headset issue I was having the other day. And I still can't fix it. But let me take a quick look again. Just finished getting set up as well. Sorry, getting set up, and let me see here. Oh yeah, one last thing I wanted to check. I did restart some things. I completely killed the QuestLink app, hoping that maybe, and like going, like, because even when you shut it down, it's still running in the background, because of course it is. And let's see, the headset's on. Alright, I don't think it's going to work. So weird. Connected and active, but I can't cast. This says enable AirLink. But that's... one more try. I don't want to make this about today. Today is not supposed to be about this. I want to move on to fun stuff, and this is going to be annoying if this is the priority. But let me try real quick. So this says use AirLink. So now I've lost the USB connection. Enable AirLink. Yeah, well, okay, so that doesn't work. And in fact, I think, if I remember correctly, I don't want AirLink anyway. I want to use the USB connection. If I click on those controls, it takes me here, which doesn't really... Alright, I give up. So, we'll see. That means... Let's see, what are my priorities for today? Alright, so this is... I'll give this one more shot later for like 2 seconds, but I'm not really going to spend any real energy on it. Alright, so where are we at? Dynamically resizing the book. Git status-s. Git diff. Alright, so... this all kind of worked. I don't really want to spend any more time on it right now. So adjusting height. I think what I'll do, I'll just mark this as a to-do. I'll just say seems 90% working. Just buggy. Fine. Alright, so that's that. And then... right, the padding I adjusted, that seemed fine. Again, I can always tweak these things later. I did resize the book. If we go to 3D... see, it's 3x4. Let's go back to 7 on that. And let's bring this up to there again. That looks good. So it looks skinny, which is fine. I'll do one last run on the headset. This will be the last little check I do, and then we're just going to merge this code and move on to sentiment analysis. because that's where I want to be spending my time today. All right. Let's run that. First run of the day is always going to take longer, so I will take a sip of coffee. And then let's bring this in. Don't expect this to work. It's really annoying. It's weird, and like the phone doesn't work either. Like the phone, I don't know. I think I was able to Wi-Fi cast briefly. I don't know. Whatever. It's in a weird state. So test this one last time, and then we're going to move on to sentiment analysis after merging this code. It's still deploying, right? Yeah, got this window up. Do the permissions. And there we go, permissions up. Yeah, I think I got a new headset update, and then it just kind of broke everything, which is, you know, fantastic. So you're just going to have to trust me that the app is launching right now. And no cast, right? Okay, well, create a new boundary. No boundary was found near you. Whatever, we'll do that. Oops. Let me pick a random page. Here we go. Is it trying to scan? No. So I'm having this problem that I have sometimes where now I got to kill the app because I can see like in the logs I don't have it. Just tried to use my mouse to close the app because I've got the AR overlay, which is kind of funny. All right, let's launch it again. Apps, unknown sources, and we'll launch reading room. All right, there we go. Now I can tell it's definitely going to work. All right, processing. And let's just make sure. Yeah, this is working great. Yeah, great. Awesome. Call that. I'm calling that done. Actually, well, let's give it another moment just to make sure it's not infinitely expanding. Okay. Cool. Calling that done. Still a little buggy. Still some things I don't like. So I'm going to do /add_files.sh, my little shortcut. I probably could turn that into a more efficient approach. Okay, git commit -n, turn off vertical resize for now. Git push origin. Where is that? There we go. Quick little skim, make sure I'm happy with everything. Yeah, turn that off, otherwise small little file. The book scene, made some changes. Oh, this. All right, probably should clean that up. Okay, main.gd. Let's clean that up because I don't want it. Was it chunk num 2? Yeah. And then this random await. And then anything else? Just some movement around of some things. this file, once again, always wants to change itself. Page text. Get parent. Right. Oh. Right. That's still there. Yep, see, this is why we code review. Interesting. I don't think I think when I run it on the headset, this doesn't show up. Because I think... Yeah, because the file... To access a file like this, the file's got to be there. And I think on the headset, the testing folder doesn't exist, so then it ends up being empty. Which is fine. Might have to think of a better way to do that kind of testing. Yeah, text container, get children. Right, we no longer need to do this comparison because now we have a text container. Yeah, so switched to having a container for all of the rendered text chunks. This means we don't need to dance around the template. Anymore. Also, what's the other piece of this? We can move, resize, etc. that container, and it'll affect all of the children. Current line index. Huh. That was on page text? And that is current line index. Oh. I was like, the space. What I'm confused here. So that's an integer. Why did I delete that? That might have been a mistake. Wow, I don't make mistakes like that very often. So when page text is updated, if it's a new page, yeah, we want to set it back to 0. I don't remember wanting to touch that, so I'm going to go ahead and assume that that's a mistake. All we did was, instead of self.addChild, we go to the container and add the child. And then we added a step here where we try to resize the page. That's it. And because we have the container, we no longer need to care about making sure we don't delete the template. Again, I'll say it. This is why we code review. All right. Now we're good. It didn't seem to cause any bugs in the app, but you never know. And I'll just call this cleanup, and we'll push that up. Yeah, there's cleanup. Cool. Squash and merge. Don't think there's any other issues. If there is, one little ritual I will always do. Let's build all real quick. Not that it matters, but might as well. and run the entire test suite on the off chance that maybe somehow magically something broke. Hey, Scroll, how you doing? And if something did break, I'd rather know now than later. But this doesn't need to, I don't need to babysit this. Well, I guess I kind of do, because this is going to block me right now. It's kind of annoying. Because I can't close Godot and I can't update the code base. Well, I suppose I could. Oh, did this not get saved? Hold on. Seriously? I didn't save the file. Ah, did I already merge it? I already merged it, didn't I? Oh, well. Okay, these things happen. Well, so here's what I'll do real quick then. Close Godot. That's what happens when you move too fast. Git stash. That's gone, right? Git checkout main. Git pull origin main. Git branch dash D. Was it dynamic something or other? Yeah. Git stash pop. Git status dash S. Git diff. Oh, man, it keeps. These files are really annoying. They keep removing themselves and then re-adding themselves. It's very, very annoying. All right, so now we'll just run the whole test suite. And then I can relaunch Godot while that's happening and start working on the next thing. And what I'll do is I will edit this. And I'll just compare the results to this. All right, so yeah, that's all fine. That's all expected. Let's wait for that to finish. So, sentiment analysis. I did briefly research this before. Didn't I bring up a couple of pages on my phone? Hold on, let me take a look at something. Oh, right. Well, there's sentiment analysis, but there's also like core human emotions. Because I do care about sentiment analysis, but I do also care about core human emotions. And also like core story emotions was the other thing I was looking up. Which I think this was the article I found before. Yes. Okay. So this is saying, don't know how accurate this is, that, you know, we've got exhilaration, suspense, fear, and they're made up of things. Okay, this is useful for me. So I guess in literature with stories, if this is what storytellers are going to follow, then I might be able to detect this in the text and then map it to sound, map it to visual. Well, maybe not necessarily visuals, but color. I wonder if I can like just adjust the color of the scene. All right. So there's that. Close some of these things. And hop back over to there. Ah, test finished. 78.14, 78.12. 6, like 5.9. 6.8, but again, I'm streaming, recording, etc. This usually goes up a little bit because of that. In fact, all these failures are probably because of that. Was it 98.4? Yeah, but it took like 13 seconds. Yeah, so failure due to running while streaming. I could also just increase these thresholds a little bit on these tests to make them a little more generous. Like this one's probably set to 4 seconds. This one's probably set to 9.5. This one's probably set to 6. But anyway, I know the final score is right. And that's what I care about. All right. So resize book based on text. Let's close that out. I did create a bunch of little tasks here. I did want to refactor things for sentiment analysis, but maybe we'll get to that in a little bit. So this might be the next thing I do. And then like dynamically loading the scene based on those emotions. Add a couple of new scenes, optimize the headset performance. I have some notes here. I think I even have like another one over here somewhere, right? I think it was that. Yeah, now I can close that tab. Here, I'll bring this over as well, because I had done a couple of little bits of research, fixing jitter, stutter, other things that Ultimate XR Developer Guide. Okay, so those are all fine. And then, is there anything else here I care about? I will bring that over to in progress. Only OCR one page. That's easy. Title pages don't OCR. That might not be easy. These two might be tightly coupled. Like might not be able to fix this without redoing how I do OpenCV book detection. So I'm not on. I'm hoping I don't want to be down this road just yet. Improve feedback on detection. So strategy for prioritizing environment changes. Let's do that now. UX headset quality of life improvements. Yeah. Yeah, these are some things like I want to try to do before District Arcade, which is on the 25th that I'm presenting at. I don't think I'll get to all of these things, but whatever I can get to before then, just so the app is as stable as possible. So I'm kind of trying to sprint towards that. But let's talk about sentiment analysis. So my old notes here. Take an expanding circle approach. Middle circle, we do nothing. Actually valuable, just basic atmosphere that's good for any book. So that means if we don't know what the sentiment of the page is, or even like when we first OCR'd and we're just starting to display text, at least drop them into a very vanilla basic scene and bring in some pleasant classical music, pleasant tune, just to relax the reader and let them get into reading. Once we know that there is some sort of fundamental emotion going on the page, right, then we can layer things on top of this. But when in doubt, at least we're giving the readers some environment to hang out in. So level 1 is, let's figure out those core emotions. So I put happy, sad, fear here. I can use this as sort of my notebook here. We can then change like the music, lighting, and color to complement those emotions. Diegetic is not spelled correctly. Dietetic. Is it diegetic? Artistic elements that are perceived as existing within the world depicting a narrative work. Yeah. So, just a misspelling. So, diegetic elements, you know, birds chirping, you know, if there's a castle, like not show you the castle, but give you this like shadowy kind of feeling that there's a castle nearby. Level 3 is context-specific diegetics. So this would be a little more specific than just vague birds chirping, but like if the story is talking about a hawk, like, you know, bring in a hawk versus just some generic bird. You know, if the castle's described, bring that in. And then I don't think I'm ever really gonna I'm gonna completely ignore these later levels of like what could be. I don't think they're necessarily relevant. I think for this VR app, I really want to focus in on really these first 3 levels. Nail the initial atmosphere, bring in some light and color and music based on emotion, and then layer on obvious diegetics like birds chirping or the sound of the breeze or a fire crackling kind of thing. And just let that set the mood for the VR app. All right, so this test report's done. Let's move. I can leave that over here. So what are we looking at then? I do have... Let me see here. Let's go. Where do I have my notes here? Not notes per se, but where's reading room, testing, test cases? Here we are. So I have files like this, and we'll go with these 2. Or this was like the start of a new chapter, that's why this is so short. Let's kill this one. Let's look at this one. Wait, that's 381? Did I mistype that? I think I'd mistyped something. Let me check my notes. Oh, here we go, 381. Yeah, I'm already, I can't even be relied on to fix things correctly. All right, so this might be good to say, like, hey, what is the sentiment of this text versus this? And see if I can start pulling things out. So what does Wikipedia say about sentiment analysis? Opinion mining is the use of NLP and text analysis. Extract, quantify, and study affective states and subjective information. Deep language models. Also, more difficult data domains can be analyzed. News articles where the author has an opinion. method describes individual words and phrases in text with respect to different emotional scales. Subjectivity, objectivity, identification. Which is something I probably don't care about. Let's just assume, like, the author's telling the story however they're telling it, so can we just determine the emotion? That's the thing, I may not even care about sentiment analysis. Application recommender systems. Of text checker. Let's just see if there's like a tool. You know what? I'll just go to ChatGPT for this. Are there online tools that are free where I can paste some text and it will give me a sentiment analysis? Several free tools. The free sentiment analyzer. Get a sentiment score from -100 to 100. This free tool will allow you to conduct a sentiment analysis on virtually any text in English, where -100 indicates a very negative. So this is just negative or positive. Plus other insights, entities, themes. Generic model trained on real users' comments. All right, fine. Let's give it a whirl for this one. I'll get rid of the top here. Here we go. Oh, does it? So it pulled out a bunch of things. It's saying this is like the what, the strongest maybe? Or the word great? I don't see the word great anywhere though. Oh, such great powers. The document is negative. Wow. It is the Call of Cthulhu. 5.6. Ah, here we go. Interesting. Okay, so detected themes. Frightful position. Oh. So this is text from, this is actually text. It's like the theme is not advancing humanity. That's just text it pulled from the sentence. And then we have keywords, which are mostly negative. But again, it's just positive, negative. All right, fair enough. So my process for this is I'm going to look at a couple of these tools online. I'm sure there are a few. and then narrow down, like, what is it I'm actually trying to do? And then the question will be, are there libraries or tools I can use to implement this in code? So if I find something online, like, for instance, even just pulling out keywords is kind of useful for me. Like, keywords or phrases. That could be useful for me then do, like, even if I just did a basic lookup table for those words. But yeah, and then figure out, like, what's the coding approach to doing this on OCR text. Since I'm doing OCR in chunks along the page, yeah, I guess the question will be, yeah, I'll have to, like, maybe figure out the average emotion overall from the page, because I can't really know where the user's looking on the page, not yet. I think a future version of this app, which is part of the original dream was like, oh, you can do eye tracking in VR, which is true. There was like one headset that did it. If I did eye tracking, I might be able to figure out where the user's looking. The thing about eye tracking that's funny is people look all over the place. Their eye dances all over the page when they're looking. So it's actually kind of hard to figure out where they're looking at any one moment, but you can kind of average it and figure it out. So I could at least figure out, like, are they on this line or are they down here? And then take the sentiment of this and match it. But that's way off. I think that's a far future thing, because most VR headsets don't let you do that. So I think for now, I'm just going to have to take, like, the whole page and then basically average the sentiment and average the emotion for the whole page. Let's see here. Positive, negative, neutral. Thanks. Okay, so I'm thinking maybe I don't actually care about sentiment, but instead I am looking to pull out keywords and understand the core emotions occurring in the text. Is there a word for this? Are there tools? Are there tools for this type of detection? And yes, there is a difference between sentiment analysis and what you're describing. Let's break it down a bit. Emotion detection or emotion analysis. So sentiment analysis measures the overall positive negative, which could be useful, but not a priority, right? All right, I've been using sentiment analysis in my head as the term, but clearly that's wrong. Identifying emotions. Keyword extraction. Pull out main ideas or terms in the text. Key phrases. Project deadline, team morale, etc. Topic modeling. Group-related texts into themes. So what you want sounds like emotion and keyword topic extraction, i.e. understanding what the text is about and how it feels emotionally. Extracts emotions, key phrases, entities, concepts. Yeah. Language understanding. natural language. Text to speech, speech to text. Text emotion. Typo. $31, I'll take it. Discovery. Cloud free tier. Okay. IBM Tivoli. Ooh, that word gives me flashbacks too long ago. All right, I don't care. Meaning Cloud text analysis demo. I love when ChatGPT brings up stuff that, wow, like the site doesn't even exist. Cool story. Hugging Face zero shot emotion model. Ah, but these are... What is this? Pre-trained NLP model to analyze sentiment of financial text. All right, so this is financial specific. What else we have here? This one. With this model, you can classify emotions in English text. 6 diverse data sets: anger, disgust, fear, joy, neutral, sadness, surprise. Okay, so that's where, okay, as much as I may want to detect these things in text, I may be limited to whatever tools are available to me. So this is why this little bit of research step is important. Because as much as I would like to just jump in and try to detect these, I may be limited by the tools. All right, the model is fine-tuned. Run emotion model with 3 lines of code. Sure. Please log in with your Hugging Face account to run the widget. Yeah, I don't want to log in right now. I mean, I have an account. Just, I don't think I have that password on this machine. Okay, well anyway, here's an example. In Python. So we get our classifier, and we call it with I love this. And then our output scores. Anger is super low, disgust super low, fear super low, joy is almost 1.0. So it's joy. Okay, so I don't think I can run any of these models. I'm trying to avoid with this project doing anything that I need a server for. I'm kind of running up against the limits of that, so I may have to run a server at some point to do some more advanced things like this. But I don't think this is ever going to run, at least not for the moment, on a VR headset natively, which is what I'm trying to do completely with this app. All right, let me just keep trying to find like one of these where I can just test them in the browser. Text analytics, blah, blah, blah. I ask for a demo. You don't have an online thing. Great. Barclays misled shareholders. Yeah, again, all this is like stock stuff, which, you know, makes sense. Company files that are a quarterly report, and you want to quickly know, is this more negative than their last report? By the way, it's saying the word grandeur is wrong. Did I mistype that, or is that... Yeah, I did mistype it. Grandeur. Grandeur. Okay. Words, phrases, meaning. You provided categories, topics, and organization. Blackwood. Amazing. This is probably useless to me. Oh, this is cool. So keyword extraction. Spacey. I know Spacey. I haven't spent a lot of time looking at it, but it keeps popping up every few months for me. I think I saw something about it at PyCon. Industrial strength NLP. I guess there are two things I am looking for at the moment. One is basic emotion. You know, 6 to 12. 6 to 12 emotions. Like, categorize a block of text overall by 6 to 12 emotions. The second is pulling out keywords like birds, grass, nighttime, etc. I also need this to run in C++ directly on a mobile phone. VR headset's basically a mobile phone. On mobile phone level hardware. Perfect. Very clear. Technically focused goal. Blah, blah, blah. Entirely offline. Mobile class hardware. Quest headset. Yeah, Quest headset. Motion detection. Lightweight C++ on-device options. Is usually a text classification problem. You'll want a small transformer or classical ML model that can be exported to ONCS or TF Lite. I've heard of ONCS before. Open Neural Network Exchange. Ah, right. Built to represent machine learning models. Is there a developer section? Docs? Fine. Can be compared to a programming language specialized in mathematical functions. Okay, fair enough. Yeah, okay. This all makes sense. Just checking in, seeing if anybody's on the other channel. Okay. Options are distill Roberta emotion model from Hugging Face. Oh, this is the one that I stumbled upon because I just went to this list. Okay, so this was all text classification models. This first one was financial, but that had 900, almost 1,000 hearts, like 1 million downloads. This one also, 1 million downloads, almost 500 hearts. So I was like, okay, like let me skip this one. I was gonna look at, like this one also is similar. Distilbert. Uncased, fine-tune. Interesting. This is the beginning of 2023. This is the end of 2023. This model is a fine-tuned checkpoint of the base uncased. Parent model. For the sentence like this film was filmed in country, will give radically different probabilities for positive label depending on the country. Okay, so I have some options here. Be nice if I could like order them by. There's more filters there. There's probably a lot of them, right? 100 pages worth. I haven't run anything on Onyx yet. Libraries, languages, licenses. Well, licenses is probably something I'm going to have to care about. All right, anyway, so it's saying I might have to get on that path, which I really didn't want to do. Where else was I on this kind of journey? I think I dumped something here at the bottom. Hold on. Yeah, hosted API. The app works okay right now, but there are some problems. So I can't run Grammar Checker natively on the headset. That would require, again, I mean, I think there's apparently some neural networks and stuff that do a better job of grammar checking these days. OCR is slow. That also would be faster if I could run it not in C++, not on the headset hardware. OCR is also resource heavy. Yeah, so add to this list more reasons why maybe I need a hosted API that the app calls. I really don't want to do it. I was really hoping this thing would be fully on the headset. Honestly, as a developer, I would move faster if I had a server. Because then I could implement everything in either Python or just, hosted models and C++ like running on a server. Much easier for me than trying to build and compile libraries to deploy to a VR headset. So I would move a lot faster if I could do that. Okay. So this is saying this Roberta emotion model is an option. TinyBert mini LM emotion fine tunes. 1/10 the size of BERT, still accurate. So I would convert it to ONCS and run with C++ inferencing engine. Okay, I've never done that before. Might be a fun experiment though. Like, could I do that? Classical ML. if you don't need nuance, train on bag of words or TF-IDF with datasets like Go emotions. Easiest to embed directly in C++. No heavy runtime. Cool. Maybe I'll go the classical ML route. Because I don't need much. I'm not trying for the emotion stuff. I'm not trying to like really nail it. I'm trying to just like, is it more happy or is it more sad? Yes or no? And is it clearly more one than the other? If it's vague as to which it is, well, again, fall back to neutral. And this isn't critical. This is, again, that's the thing, is like when in doubt, I can fall back to neutral. And only, or keep the music the way it is now. If the previous page was stressful, keep the music at that same level unless there's a compelling reason to change it. At least that's what I'm thinking. It's saying I should start with and load onks at runtime. Runs fine on mobile CPU. Gives you a compact 60 megabyte and easily portable to Android Quest. Keyword extraction can be done without neural networks, which is great for your use case. So rake, that sounds familiar. Rapid automatic keyword extraction. Very simple. You can port rake to C++. Open source ports exist. No ML. No heavy compute. Yake, yet another keyword extractor. Uses statistical features, term positions, small and open source, easy to re-implement. Spacey, if Python's allowed. It is not. Harder to port directly to C++. Fast text embeddings. Fast text is C++ native and very light, works great offline. Start with rake yake. Runtime footprint. So this will, in fact, be running on a Quest 3. If I have the option to run on C++ or GPU, that would be a bonus. So I can pick whichever is better. Note also that I'm already running some other heavy operations. A VR app to start, obviously, but also Tesseract, OCR, and OpenCV. So I do care somewhat about resource budget, as I don't want to max everything out. That said, there are multiple CPU cores, and I assume I'm not using all of them at once. Let me think here. I also don't need to be very accurate. Just good enough to know if a page of text is mostly happy, sad, etc. Ideally, we'd also know if the current page is more intense than the previous page. But we could compromise on that. Keywords matter a bit more, but at the same time, just trying to decide if the VR environment is outside, inside, day, night, etc. So mixing up grass and field should be fine, as I'm not trying to be super accurate. Let's see what it says to that. If it has a thought. Either way, I'll probably just start with something basic anyway. I don't want to implement something heavy, even if it thinks heavy is an option. Yeah, Snapdragon QR2 Gen 2 processor. 6 to 8 emotions, keyword extraction. Tolerant of approximate results. So it already knows I got the page text from Tesseract. Tokenizing. Okay, I didn't think about that. Oh yeah, why didn't I do tokenizing? Why didn't I think about tokenizing? I mean, this is what LLMs use under the hood. I mean, when you tokenize, you're basically... I mean, actually, assuming that's fast, which it should be, first 200 words. Why wouldn't I tokenize the whole thing? But, yeah, when you tokenize, I mean, basically what you're able to do then is, like, the word queen and the word king have a mathematical short distance because they are similar in many ways, even though they're completely different words. So tokenizing actually does help with trying to find like what words are like similar enough to each other, because in some dimensions they are different, but in other dimensions they're not. And so that's where like tokenizing is interesting. I'm surprised I didn't think about that before. It's saying, okay, so you tokenize, then run an emotion model. Then we categorize those emotions. Then use rake or yake still. And then combine everything. Low resource C++ strategy. So option A is use a tiny transformer. Quantization, use ONC's runtime tools. So it's like 40 megs. Shorten text. So just let it categorize it. With quantization, you'll get 3 to 5 milliseconds per inference on a single core. Classical logical regression is the ultra lightweight option. Super tiny and don't need deep semantics. Go emotions dataset. It's a few hundred kilobits. And you implement prediction directly in C++. Ooh. You can train this in Python once, then deploy it as a simple array of coefficients. Blazingly fast, i.e. sub-millisecond running time. It's tempting. I mean, at 3 to 5 milliseconds. The only problem is if I go to this route, again, I'm getting back into the hell that is potentially building libraries for C++. I mean, luckily, the last time I did this, which was not too long ago, it was for dictionary spell checker, which didn't work out. And like the spell checker, luckily, didn't require a lot of dependencies, and the dependencies it needed I already had installed, so maybe that's okay. Keyword extraction. Perfect and cheap. Rake yake. No ML model needed. Available in pure C++. Very simple to port. Word, co-occurrence frequency and position scoring. Words on small text chunks, a few hundred words. Keywords will reflect visually descriptive nouns which align with your inside-outside day-night goal. Option B is fast text. If you want to slightly boost accuracy. Facebook C++ text library. You can train it to detect environment type directly. Runs incredibly fast and natively in C++. Yeah, this is bullshit. Tesseract in 500 milliseconds per page. I wish. Again, I still think I'm doing something wrong there with my settings because it takes 25 seconds per page. 200 megs of memory. Again, this is a lot lighter, but I worry that if I keep doing things like this, I'm going to hit my head on the ceiling, where I'm going to run out of resources on the headset just when I'm trying to implement, I don't know, beautiful animations or something. Onks can... Oh, interesting. Onks can offload to the GPU. I had a question. This all sounds great. One bit of extra context just in case it changes your recommended approach. Obviously, Tesseract OCR isn't 100% accurate, so some words might be off slightly. Do any of these approaches handle that better? Small misspellings. Missing or merged spaces, yeah. Stray punctuation and capitalization, yep. Methods relying on exact token matches can degrade quickly. Models or methods that use subword or character level representations are much more resilient. So, for emotions, still stick with the transformer. For keywords, you might need adaptation. Rake alone isn't ideal unless pre-cleaned. Oh, interesting. Subword transformer. So like nighttime might still partially match night and time. They were trained on noisy web data. So keyword extraction sounds like that's going to have a harder problem. Rake with light pre-cleaning. I can't do it. Frequency-based correction. Strip weird characters, split concatenated words heuristically, then run rake. Confidence scores to decide when to apply corrections. Yeah. Option B. Fast text's subword embedding. Make it resilient to OCR errors. Grass and grass produce similar vectors. Yeah, as they would. Hybrid. I don't want to do hybrid. Since Tesseract gives you per word confidence, you can combine that into your emotion intensity. Huh? Okay. All right, so yes, please. Fine, let's just let it do its thing. See what it comes up with while I finish my coffee. So the biggest question is going to be how hard and annoying is it going to be to install the thing I need. This was interesting, closing it. Sentiment analysis, I don't actually want. I thought I did. All locally, no network. Yeah, fine. Quantized Distilbert. So here's the build guide for ONX runtime. Let's take a look at that. To build ONX runtime for Android. Install Android Studio. Blah, blah, blah. I should have all this done. I think I have SDK Manager. The Ninja generator needs to be used to build on Windows. Using the paths from our example. Cross-compiling. Okay. I don't want to do this. Build prerequisites. We would need oncs. And then Facebook's library. Archived. Okay. So no one's maintaining this. Okay. Last update was from 2019. What about the issues? What do the issues say? No one's opened an issue in over a year. I don't like it. So you're going to archive it, but you're not going to tell me what the alternative is. Has someone forked it, maybe? Okay, well, preparing the model. All right, so I could create a virtual environment, install some libraries, and then run some commands, and in theory then I have a file. That's fine. I can run this on my other machine, which is better set up for Python. And then here, okay, see, I'm gonna need to install oncs with all its files and everything. Okay. Oh, this is saying just create a file for it and just dump all this there. Export tokenizer from Hugging Face. This should still, like, I don't have time to do this in the next week. All right, here we go. Okay. So who has branched off from this? I guess a ton of people have. I don't know why I'm doing this. Ah, I didn't mean to click that. All right, whatever. Let's go look here. Forks from... Oh, most starred. You know, 2 years fine, because it's when it got forked 2 years ago. Here we go. Not command click, control click. Fast text plus Bloom embeddings for compact full coverage vectors with spacey. Is an extended version of fast text that can produce word representations for any word from a compact vector table. Bloom embeddings. Okay. Build from source. You can pip install it. Is this Python only then? They mentioned spacey. All right, well, let me understand how it works at least. So originally, fast text stores words and subwords in 2 separate tables. And the subwords are stored separate fixed size table by hashing the subwords. Only support the word table. In order to store word and subword vectors in a more compact format, we turn to an algorithm that's been used by spacey all along, Bloom embeddings. What is a Bloom embedding? Also called the hashing trick. Hash embed can be used to store distinct representations in a compact table by hashing each entry into multiple rows in the table. Each entry is the sum of multiple rows. So Apple is stored as 2 hash rows. Huh. Okay. What other notable forks are there? Faster text? Nice. Yeah, that's fine. And that's it, right? What if we go all-time forks ordered by stars? So again, floret, extreme text, and that's it. So extreme text hasn't been updated in 5 years. Okay. This fork is also 7 years out of date. Cool. So it's floret and fast text. Those are the options. Looks like fast text is abandoned. I also think that although this is a good approach, I'd like to try starting with a vanilla C++ approach that does not require me going down the path of building and installing libraries that can be built for Windows and Android, as I need to do that to properly test my app. It has been a pain in the past to bring in new integrations like OpenCV. I want to get a quick prototype going. So what are my options for C++ only with out of the box library dependencies for this? Oh yes, a very smart move. Thank you for complimenting me. I'm clearly so smart because ChatGPT tells me I am. Aux runtime, TensorFlow Lite, fast text. Adds a lot of build friction. Yep. Prototype quickly in pure C++. Yeah, let's do this. Header only or STL only approach. No external libs. No builds beyond what you already handle. So use simple sentiment emotion word lists, counts, and weights, and weighs them. Keyword extraction, pure C++ rake-like frequency score to find important nouns and descriptive words. Something that feels intelligent and runs instantly with zero dependency. We'll use a small dictionary of words tied to emotions: joy, sadness, anger, fear, disgust, surprise, neutral. Then we count occurrences with fuzzy partial matching to survive OCR typos. Okay. Simple word list. Cool. It's not bad. I mean, this could be good enough to just approximate the intelligence of this. So here's our text passed in. Gotcha. So we take that text. I think, yeah, two lower. Okay, so we do some trimming and cleaning up. Tokenize it. Okay. Score the emotion. And results is an emotion score, which is a struct made up of an emotion and its score. Okay, so for each of these emotions, we're going to give it a score. And then we have a dominant emotion function, which I don't need. I'll throw that away. You know, this isn't bad. I think I'll do this, because this will take no time at all to implement. And again, as long as I can, again, even if it's a little bit buggy, I can always go back later, rip this out, and replace it with something better. compiles anywhere. And then keyword extraction. Simple frequency-based keyword extraction that removes stop words, scores by frequency and word length, returns top-end descriptive tokens. So stop words. Okay. So we have our text. Again, we transform it. iString stream. Okay. Remove if. Okay. In the stop words, right? Right. Sorted, sort out. So if we put it together, the grass and trees with misspellings, that's fantastic. Analyze emotion, get the main emotion. Extract keywords. So it's saying, and again, I can't trust this, so I'll run it myself. So it says the sun shone over the grass and trees. Everyone felt happy and calm. Mostly joy. See, it pulled out the keywords, but they're misspelled. And then it got keywords. Right. Yeah, if it works well, swap it out. This is great. I'll use most of this code, but we'll skip things like main and dominant, since I'll call down to these methods from GD scripts. Can you provide an expanded list of matching words for emotion words? Also, one other thing before I get to coding, because I think I can just go implement this now. Also, the keywords returned will, of course, have misspellings in them. I did implement a spell checker in C++, but would prefer not to use it. I'll just say it that way. Are there easy ways to take words like grass and field and map them to like grass for example. Not sure what I'll do. So I can spawn the right assets in VR. Are there easy and simple ways to take... Oh, I said works. I meant to say words. Whatever. You can expose them, directly call them. Give you a simple, fast, no library, fuzzy mapper that can take grass and turn it into grass, field, make it field, etc. Cool. So there's our expanded word list. You don't need all 12. Great. Lightweight OCR tolerant keyword normalizer. Since you don't want to bring in your spell checker, it's not real spell check. It just matches similar looking words to known vocabulary. It runs fast and needs no extra data files. Gotcha. Okay, so I have my list of known words. Compute edit distance or prefix similarity between and known words. Pick the best match if it's close enough. Okay, so I've done Levenstein distance before. Levenstein, my old friend. The only issue with that is, you know, if OCR can on occasion like really garble a word. And so you could have a word that's similar to field, but really it wasn't the word field at all. And then we may end up saying like, oh, they must be outside when really they're not. That's probably okay with enough text. I mean, one, I could threshold it and say, look, if there's just one word telling us that we're outside in a field, ignore it, because we don't know it for sure. And it could have been an error rate. And then the other thing is, like, yeah, if a certain word shows up a couple times, it's likely I can trust it anyway. Okay, so I could probably just, with a little bit of basic thresholding, eliminate enough of the noise. Okay, I've seen enough. I don't need to run anything more. Let's code. Now that I'm practically out of time for my ability to work on this today. In fact, let me check my afternoon. Yeah, I do need to stop soon. What is that? Okay. I need to make a rule where people can't book time with me after like 9 a.m. on the day of. Yeah, great, thanks. So yeah, I do have to drop soon, but let's get on with this. So okay, so those changes are there. This is fine. So we're going to do a git checkout -b. Basic emotion keyword detection. We'll add files.sh and then git commit -m. Leftover code from last PR. Oops. Git push origin basic Cool. We'll call it basic emotion and keyword detection. We'll mark this as in progress, and let's roll. Code dot. I didn't have VS Code up, right? Nope. All right, so we have our book scanner. I'm going to expose these interfaces through here. Trigger scan, set camera texture, pause scanning, resume. Manually set images, compute text similarity. And if I'm remembering correctly, if I go to register types.cpp, yeah, book scanner is the only thing I expose. So that is my only interface from code. There have been some experiments I've done where I've exposed other things to Godot. Speaking of, I do like main here. Whoa. Yeesh. Interesting when I go to 3D, I get like some buzzing audio. All right. All right, so what I'll do is I'll create these here. And let's just copy paste those out. And where's the .h, by the way? Right. Let me figure out these interfaces here. So your GD extension might expose something like map keyword. What does map? Why would I? All right, so analyze page is going to be a dictionary. So how was that implemented? Is that like an unordered map? Is that what that is? All right, let me just borrow this. I guess sounds good. What would be the method signature for analyze emotion simple if I'm calling it from Godot? So we would pass a Godot string and return what? So here's what I'll call them. Let's get rid of that. Again, this will be the same signature. I don't know why I called it OCR text, but let's just call it text. And then we will get emotions. Why do I keep missing the O on that? I'm gonna blame my keyboard. Excuse for me to buy a new keyboard, right? Let's ground this to Godot 4.5 extension, C++ 17. I think that's true. I think I'm on 17, not 11. If you're binding this for a new GD script, you'll want to take a string, right, and return either a Godot dictionary, if you want the top emotion. Can I just do that? Can I just do a dictionary? I can. All right, that works. And then for this, I'll do get keywords. And we'll do an array. Okay, so that's a Godot array. All right. Let me grab this. Go all the way to the bottom with this. Yeah, I don't know. I'll figure out the right order for this code. Okay, so then I don't need anything too complicated. I can just do get emotions, get keywords. So take those signatures, put them here. We'll have text. We'll have text. And again, I'll just do get emotions, get keywords. And where is that? Where does that live? Cool. So I'll steal this. I'll work from here. And these method signatures are going to look very similar to these. So again, let me simplify that up. Call it text. We'll plop that there. Get emotion. Get keyword. And then this is going to have to be like an array. And this is going to be a dictionary. Okay, so since my namespace is Godot, that's easy enough. Cool. So now the question is going to be how to convert things, like do the math and then convert it properly back. So let's go back up here. Again, we'll start with this one. So this is saying do like a struct emotion score. And in this case, it's saying like a standard vector, standard string. Okay, can you update your version of to handle the method signature? Yes, 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 fine. It's got a bunch of imports. I may or may not need some of these. Okay, so it's saying we'll still do standard string, vector, string, emotion words. Okay, so the simplest way to do this would be to cut these, drop down, put those there, and then we'll tab this over. Little ugly. I may put this, pull this out to a file somewhere, load it in, keep it in memory. I don't know. I mean, it's just ugly to have it here, but also not a huge deal. Still called it emotion words, right? Didn't change that on me. Great. Oh no, I've hit my free plan limit. That's fine. Let me start by just getting this working. This is all I'm going to get done before time's up anyway. So if I pull this over, by the way, do I have an array somewhere? Typed array. Yeah. This won't compile unless I do something like let's just do array. Fine. Just so it shuts up. All right, so this is that code. Right. Bind the method. So yeah, I should be able to now test this and confirm it works. And if it works, then go pull over the other. I will pull over the other now anyway, just for the heck of it. So I don't lose that original code, and then I can work on it later. But let's see here. So here was that first emotion code. This extract keyword seemed fine. So get keywords. Unordered set, huh? Yeah, no method unordered set. Not unless he did some sort of import that I missed. Can I do that? C-type CMath. Okay, I may have just have to comment this out, which is fine. So yeah, I think I'm on C++ 11 maybe. Wait, so that's the emotion. So this is that, and then motion keyword. Right, this is where he got those keywords. I asked him to tighten it up. Sure, there's that list. Levenstein distance, which I already have. I could compare this to see if this is better than what I've got. Hey. Ariano Throwaway. Nice to see you. Yeah, I mean, I didn't want to implement... Well, first off, sentiment analysis is what I originally thought I needed. But that's... Well, first off, let me ban this person. Hold on. It's like it's been a while since I've had to ban somebody. I was starting to feel like maybe they stopped caring about me. Yeah, so originally I thought it would be sentiment analysis, but sentiment analysis is really just, is it good, is it bad? And what I need is emotions and keywords. And once I have emotions and keywords, then what I can do... Oh, how did this get dragged out? Did that get reset or something? Hold on. Oh, there we go. Yeah, so this is like the VR app that I'm working on. Here's a demo of it. So I want to be able to match the scene and environment and soundscape to the content that you're reading in a book. And so to do that, I need to be able to pull out the emotion. So can I take the text from the page and figure out like, hey, what are like the core emotions that are going on? So classify it that way. And then also pull out the keywords and map those keywords to things like daytime, nighttime, rain, stormy, whatever, and then use that to alter the environment based on what's going on. So right now I've got basic scene stuff. I've started bringing in basic audio. I have audio lined up for emotion. So I have like tense music versus more relaxed, calming music. Now I just kind of need a system whereby I can pull that out. There are a lot of fancy transformer and ML techniques for doing this, but this also needs to run on the VR headset directly, and I really don't want to go down that road because also there's a lot of build pipeline library nonsense that I have to deal with to bring that in. So for now, my plan is to just implement it in pure C++. So that's what I just had ChatGPT do, was write me some code for C++ to do very basic, boring, dumb sort of emotion analysis and keyword analysis. So if I can just get fuzzy, rough keywords, pick whichever one is the most similar to the most often occurring, same thing on the emotions, then based on that, I can, set the scene a bit. It might be a bit buggy and I'll have to rewrite it later, and I'll probably later have to bring in maybe some models, maybe some other, even if it's just basic machine learning type tools. But at least I'll have something to start with. So I'm trying to just get the bare bones version of this working. Let me refresh this. Yeah, I was gonna say, I thought I had like a couple more likes than that. Let's see here, what do we got? Past noon? Yeah, I gotta stop in a minute. Yeah, by the way, where is my Levenstein distance? Let me compare that real quick while I'm here. Yeah, compute text similarity. Interesting. So so this doesn't handle Godot strings. This does, my version. See, this just gets the, yeah, it's a little bit simpler. I handle case and sensitivity. See, this didn't do any of that. Normalize white space. Okay, and then I actually did I have like normalize white space? Case and sensitive. Yeah, why even? I should just remove those. So I have ints. This is doing, I did dot length, it did dot size. OCR processed is what? A standard string? Interesting. Okay. So it went const size t. And then it did len2 plus 1. That's kind of weird. Once again, we short circuit, even though I didn't need to. Again, this was mostly AI coded as well, and I never it mathematically worked, so I didn't really code review it, but now I'm seeing some things I don't like. In any case, double for loop. Yeah, I don't know. One thing I could do is take this whole method and feed it to an AI and ask it to refactor it. All right, enough of that. Fine, let's get rid of that. It's not going to like this because it doesn't match. We've got to convert to an array. So okay, I could make this a private. Sure, why not? Make that a private. See, some of this is ugly too. Like, just put in a little bit of spacing. We write code for human beings. Let's make it a little bit human readable. What are we, animals? Live in a barn? Oh yeah, where is our Lowenstein distance? Do I return an integer? I return a float. Float. Really? Do I not have... Whatever. I'll figure this out later. I don't like this method signature. But either way, here's where we do the pushing back. So I could do standard string. And we'll do, call it matching keyword. What is it not like about that? Oh, that's right, because he's being clever, didn't wrap it in curly braces. That's correct, right? Sorted I first. Undefined. Oh. There we go. All right, all the same. Let's close this up and just test one block of code at a time. Which actually means get keyword is not ready for prime time yet. Comment that out. So at least we can just check get emotions works. Which that code, I think this looks ready. At a glance anyway. I can also then test its performance. I can test its speed. Yeah. Sure. I think I'm going to stop here, though, and this will be the cliffhanger. So, probably off camera, I'm going to test this, make sure it's fast, make sure it's accurate. If it is, then I'll bring this back, get it working as well, And then if both of those are working, then I'm ready to start bringing in some interesting environment changes based on the emotion of the text. Like the version of this that I have right now, yeah, I think like I was just doing something basic like yeah, like when we would get words, take those words and just grab that individual word, get its simplified text, so clean it up, and then update time of day if it's daytime or nighttime. And that works. Like I do often open a book to a certain page when I'm testing this app. And yep, the word tonight or moon will show up and it'll work. But I don't want to implement this. This is not the right solution. So I'm going to swap this out with this new code. And hopefully it should be faster, more reliable, less error prone, all those things. And then I can start doing more interesting things in the app. In any case, thank you for those who hung out with me. Scroll, sorry we didn't get to chat. You said hi, thanks for hanging. And I'll probably stream on Monday, I think. Actually, let me think here. I might not on Monday. I might have a conflict in the morning. But either way, we'll see. I may stream. In any case, have a good one, and I'll check you soon.